Welcome guys. In this video I'm going to be going through the answers on the CFE practice quiz from units 1 through 3. So for this first question, they mentioned that we have a person earning a 5% commission, but only when they sell more than $7,000. So they've written two functions for us. There's the 0.05, which is the decimal form of 5% of X, so 5% of what amount of money, and then there's a separate function of whatever amount of sales were made, subtracting 7,000, and they're asking us to pick some operation on the functions that will represent how much money they get from commission. Now remember, they're only getting this 5% of the sales over 7,000. So the easiest thing to do, I think, would be to actually just write what each of these functions ends up looking like. For example, if you did g of f of x, that means plugging that function in over here. So you would have 0.05 x getting plugged into x, and then subtracting 7,000. But this function doesn't make sense. This is saying 5% of everything and then subtract $7,000 from it. But no, we're only earning the 5% on what we sell above 7,000. So what I did was I just kind of imagined what each of these functions would end up looking like. Adding the functions together does not make sense. Multiplying the functions together, if you distributed that out, does not make sense. But if you look at what f of g of x would be if we plugged this in the other way around, then you can see that you end up just earning the 0.05, the 5%, times whatever money was made over $7,000. And that's exactly what we wanted. We wanted to say if she sold $8,000, you subtract $7,000, so there's $1,000 that she's earning the 5% interest on. For number 2, whenever you were asked to find the inverse function, you want to switch x and y. Remember, f of x is the same as y, so I replaced that with x, and I replaced both of these with y's. Now, a lot of you guys struggled with how to solve for y since there are two different ones in the equation, but just go through the opposite operations as you know them. So the first thing to do here would be to multiply both sides by the y plus 2. So I went ahead and distributed x times y and x times 2 just to save an extra line of work being written out. And so that equals 4y minus 3. Now we're still trying to solve for y, so we want to move everything with a y in it to one side of the equation. So I subtracted 4y from both sides. And everything that doesn't have a y to the opposite side, so I subtracted 2x. Now that I have a GCF here, I just factored out the y. So that's what took it from being two different y's into a single y. So this is like you're distributing backwards. If I take y out of this, I'm left with x. If I take y out of this term, I'm left with negative 4. Since this says y times x minus 4, the opposite of multiplying is to divide. So when you divide both sides by x minus 4, that's the expression you end up with. So it's important to remember that a function and its inverse just flip which number is the input and which number is the output. So if I said find f of 15, the answer is 0.5. But if I say f inverse of 0.5, the answer is 15. So either way, we're saying these two numbers are tied together by stating the difference between f of and f inverse. We're just changing which number you are given and which number you're stating as your answer. That's all that's happening with inverse functions. So this said to evaluate f inverse of 1.3, which means I'm looking at what we consider the y column or the y row essentially, and then we're stating the x value as our answer instead of given the x value stating the y value. So the answer to f inverse of 1.3 is 45. So right off the bat, you should be able to eliminate two of those answer choices. And then conceptually, remember they're saying that this is how many centimeters of rain accumulated, and this is how much time it took to get that. Well, we're saying that there were 1.3 centimeters of rain, not 45 centimeters of rain. The 45 is referring to how many minutes have gone by. We're not flipping the unit. This is still 1.3 centimeters of rain. So that's why it had to be this third choice instead of the first one. Here we have another inverse question. So switch the x and the y. So write it as x equals square root of y plus 5 instead, and then solve for y. So I would square both sides to get rid of the square root, and then I would subtract 5 to get x squared minus 5. So right now I know it's got to be one of these two choices. Now whenever they say to find the domain of the inverse, do not make the mistake of stating the domain of your inverse function. I know it sounds like that's what it should be, but don't just look at the inverse function. You actually need to go back to the original function and state the range of it. That's what they mean when they refer to an inherited restriction. The problem is this graph is missing some of the restrictions we got from the original shape. So the square root graph, especially with the x plus 5, would look something like this, while as the x squared minus 5 graph would actually look something like this. So the inherited restriction is referring to the fact that we actually are missing one part of the parabola when we look at the original function. So we shouldn't actually have both pieces coming out in two different directions. So if they say find the domain of the inverse, look at the original function and state the range of it. This graph goes from 0 to infinity. It goes up forever. So since that's the range of the original function, that is also the domain of the inverse. If they refer to any extreme values, maybe they use the word extrema or maximums or minimums, we're just looking for the high points and the low points on the graph. Usually it's where the graph is switching from increasing to decreasing for a maximum or decreasing to increasing for a minimum. That was the kind of definition we did earlier in the year for this. So they've given us a set of x values. They're saying only look from x equals -3 to 5, but that's all the graph shows anyway, so that's not a big deal. And then they've asked us about the point where x is equal to pi and y is equal to -1. It's kind of hard to read the dot. This came through a little bit blurry, but that's this dot right here. That is a coordinate where the graph has bottomed out. This is one of its minimum values, and then it's switching to going back up from there. So that point is what we call a minimum. Next, they ask us to identify the coordinate of a maximum. Well, a good maximum I see is right up here. It's where the graph switches from increasing to decreasing. So this is a high point on the graph, or a max, and that is happening at the point 0, 1. For number 6, we're given an ugly-looking rational expression here. So one of the first things you usually want to do is perform any factoring you can on the top and the bottom. Now, the factor on the top is a little bit trickier because we did have a number in front of the x squared. So don't forget that the two numbers you pick will not necessarily add up to the middle number themselves. It's that the outside and inside product, when you're foiling out your choices, will add up to -5. So -6 plus 1 was -5 in this case. The bottom was just 1x squared, so that one did work the way you expect. That's the picking two numbers that multiply to the last number and add it to the middle number, which is a little bit easier for factoring. So in this case, there were some binomials that canceled out, so the x minus 3's, but do still keep them in mind. They will affect our answers on the upcoming steps. So the first thing we're asked for is a horizontal asymptote. This is where we use our horizontal asymptote rules by comparing the biggest exponent on the top and the bottom. In this case, we have matching second powers for the x's, and I don't care about any of the other stuff. It's just the biggest exponent on top and the biggest exponent on the bottom. When they match, you look at the coefficients in front. So in this case, 2/1 gives you a horizontal asymptote of 2. For the vertical asymptote, we're looking for which x values make the denominator equal 0, but we specifically need the ones that did not cancel out. So if I wrote x plus 4 equals 0 and solved, I would get x equals -4. That's a vertical asymptote. If you look at the factors that make the denominator equal 0 that do cancel, we call that a removable discontinuity, or it may be called a hole in the graph. In this case, they've called it a point of discontinuity, because the other one is an entire asymptote. There's an entire vertical line separating the graph on the left side and the right side from that value of -4, but this is just a single hollowed out point. That's why they're calling it a point of discontinuity. So if I said x minus 3 equal to 0, I would get x equals +3 for the point of discontinuity. Here we have some more rational expressions, in this case an entire rational equation. So again, try to do any factoring that you can. The first and the last fractions did not have any factoring to perform, but this middle fraction, this was able to be broken down as m minus 5 times m minus 2. Once I had all the factors figured out, I found the least common denominator. So I see a factor of m minus 2, I see m minus 5 and m minus 2, but I already said that one, and then this one again just had m minus 2. So my common denominator, the smallest thing that all of these fractions could go into, is both m minus 5 times m minus 2. That would be the smallest common denominator. Once you figure that out, multiply it by everything in the equation. So I have 3 fractions that all have to be multiplied by this. On the first fraction, the m minus 2's would cancel, so I'd be left with just 2 times m minus 5. On the next fraction, the m minus 5's and the m minus 2's cancel, so if all that stuff's gone, I'm just left with the 3. And on the last fraction, the m minus 2's cancel, so I have the 5 times m minus 5 part to FOIL out still. Not FOIL, but just distribute. So once you take care of any of that multiplying and combining like terms, move everything to one side of the equation if it has an m in it, all the constants to the other side, I just finished solving the equation from there, and I got the answer of 6. Now do make sure that any answers you get, you check them by plugging them back into the original equation, because if any of them make an undefined value, so if you end up with any zeros on the bottom of a fraction with one of the numbers you got, then you would actually cross that answer out. We would call that an extraneous solution instead. Here I see a difference of cubes factoring technique that can be applied, because I have something to the third power minus something to the third power. So the two things that are being raised to the third power are x and 2 in this case. And then remember, we use the expression SOAP for figuring out where to put pluses and minuses. So I don't really pay attention to whether it's a plus or a minus here. I'm just looking at x to the third power is x cubed and 2 to the third power is 8. The breakdown is a squared, a times b squared. And then mine has a minus. So the same sign as the minus, the opposite sign of the minus, and then the last one is always a positive. So the SOAP part is telling you which signs, actually let me use a circle instead of making it look like a minus, to indicate which signs go in these three spots. Same, opposite, always positive. Once I took care of that factoring, the x minus 2 parts canceled, so I only had this x squared plus 2x plus 4 left, and that's the quotient. That's what they're referring to after we simplified out and factored and canceled. Here's another dividing question. Now you could do this one with long division, but I usually prefer synthetic division as long as I'm dividing by something that's x to the first power. If you're dividing by x to the second power or x to the third power, then you have to use long division. So for this, don't forget that they'll either give you the factor, in which case you need to set it equal to 0 and solve to get -2, or they may just say, is -2 a solution, in which case you would not change the sign on it, you would just plug the -2 number in as is. Also, don't forget about filling in the missing zeros. I see x to the fourth power, but I don't see x to the third or x to the second. That's why I filled in 2 missing zeros here. The first coefficient comes straight down, and then you take the number in the box and multiply it by anything underneath. So -2 times 4 is -8. Then you add the numbers in the column again. And then you multiply by the box, and you add, and you multiply, and you add, and you multiply, and you add. And so at the end, this last number is your remainder. This is the constant x, x squared, x cubed. If there had been more numbers, x to the fourth, x to the fifth, x to the sixth, etc. So my polynomial, after dividing by x plus 2, is 4x cubed minus 8x squared plus 16x minus 30. And then for the remainder, they may just say remainder of 57, or they may put the remainder over whatever you were dividing by, which in this case was x plus 2. Here I'm showing you an example with long division, just in case some people prefer this method, and there are some cases where you have to use this technique. So 2x plus 3 is what I'm dividing by, and then on top I have 2x cubed plus 7x squared plus 2x plus 9. There were no missing zeros for me to worry about. You take the first number on the inside of the box and the first number on the outside of the box and ignore everything else. So 2x cubed divided by 2x is x squared. Now that term that you write on top, that needs to be multiplied by everything. So then I did x squared times 2x and x squared times 3. And then don't forget, you're actually subtracting one line from the next. So I put it in parentheses and write the minus out front to remind myself. So I'm subtracting 2x cubed and I'm subtracting 3x squared, which gave me positive 4x squared. Bring the next number down and repeat the process. First thing on the inside divided by the first thing on the outside. In this case, that gave me 2x, but I multiplied it by both terms out front. I subtracted, brought the next number down, and repeated it one last time. Negative 4x divided by 2x is -2, but multiply it by everything out front, and then subtract those numbers. So 9 minus -6 was 15. Now this question wasn't asking us for the entire polynomial, although I do have it now. I have x squared plus 2x minus 2 plus 15 over 2x plus 3. They only asked us for the b and the g of x values. So all they wanted from me was what was in front of x to the first power and what was the remainder. So that's why the answer was the 2 and the 15 as shown. Here we've been given two coordinates, the x value of -2 and the y value of 7, so I found it helpful to plot that dot out, and then an x value of 1 with a y value of 10, so I plotted that dot. Remember, the intermediate value theorem is guaranteeing us that we hit the y values in between, so in this case, in between y equals 7 and y equals 10. So I know that I'm hitting heights of 8 and 9, for example. So that eliminated two of the choices just by saying we hit y equals 8 as one application. The other important thing to keep track of here, though, is they're specifying what is the c. Remember, f of x, that means the x value needs to be listed. So don't state which y values we're hitting between 7 and 10. We're actually describing it according to the x values. Between x equals -2 and x equals 1, we have to hit a y value between 7 and 10. So y value of 8 between those x's. Here's another example of the intermediate value theorem. So again, I found it helpful to plot out the given coordinates here. And then oftentimes they'll ask you where does the graph cross the x-axis, but this one actually asks where are the solutions to y equals 2. So in a case like this, it may be helpful to even draw a horizontal line at the given height. And then they're asking us where does our function cross that vertical line of y equals 2. Well, not necessarily from this dot to this dot, but from x equals -5 to x equals -3, we definitely cross once. And then from x equals -3 to x equals -1, we definitely cross the second time. And then this time it gets close, but does not necessarily cross it. So these are the two intervals where we do hit a height of y equals 2. It's between these x values and these x values. Here we were given a function in factored form, so the nice thing here is you don't have to do any of the factoring on your own. Multiplicity is just how many times do each of those factors occur. So according to the exponent in this case, we have a solution of -2 occurring 3 times, and then we have a solution of 4 occurring 2 times. Here's another question asking us about the zeros of the function, and again, this was very nicely factored for us. So if I set the first factor equal to 0 and solve, you subtract 1, divide by 2. So negative 1/2 is an answer. Next, if we write x squared plus 4 equals 0, you subtract 4, and then you're taking the square root of a negative number. So 2 things to bear in mind. If you take the square root of both sides of an equation, then you get a positive and a negative answer. If I just ask you what's the square root of 4, your answer is just 2. But when you are solving an equation by taking the square root of both sides, you get a positive and negative answer. Second, since we're taking the square root of a negative number, don't forget that that's what creates an imaginary answer. So I'm ignoring the negative and just saying, oh, the square root of 4 is 2. But then since it was a negative 4, I'm just attaching an I to that answer. So here's 2 more answers, plus or minus 2i. And then the last one, 2x squared minus 3. If you add 3 to the other side of the equation, divide by 2, and then take the square root of both sides, you get plus or minus root 3 over root 2. Now, we don't usually write our answers with square roots in the bottom. I expect the exam will ask you to rationalize those. So whenever you have a square root in the bottom, you have to multiply top and bottom by that square root to cancel it out. So then square root of 3 times square root of 2 was square root of 6. Square root of 2 times square root of 2 is square root of 4, which is 2. So then there's the last 2 answers, the plus or minus root 6 over 2. If they ask you to get the standard form of a circle, an ellipse, a hyperbola, whatever the case may be, you're probably going to be completing the square at some point. So first I grouped together the x's, x squared plus 8x. Then I grouped together the y's, y squared minus 6y. These numbers were not there yet. I filled those in, and I'll show that part next. And then I moved the 16 to the other side of the equation. Once you have your x part set up, and remember there can't be a number in front of the x squared. If there is, you have to factor it out. You take half the middle number and square it. So half of this squared is 16, and that's where that number came from. For the y's, I did the same thing. Half of this is negative 3, squared is 9. So add that to both sides of the equation. Then the factoring will always break down to be x and half the middle number. So you don't have to factor it manually. It's just always going to work that way. Same thing for the y's. So y minus 3 squared. I added these numbers up and got 9. This is the standard form for a circle. You do not need to set it equal to 1. That's just for the ellipses and the hyperbolas that we do that. For the circle, our center is these h and k values here and here, but don't forget to change the signs on them. So negative 4 and positive 3. And the radius is the square root of this, so 3. Remember, there's no plus or minus on this because I'm just saying what's the square root of 9. I'm not saying take the square root of both sides of an equation. Many of the conic section questions can be answered without knowing everything in detail about the shapes of the graph. So the main things to focus on are being able to find the center. I think that's one of the most important parts. So if you average the x's, negative 2 plus negative 2 divided by 2 is negative 2. And then 5 minus 3, or 5 plus minus 3 if you prefer, 5 plus negative 3 is 2, cut in half is 1. So average the x's and average the y's in the same way that you would average your test scores. You add them up and divide by how many there were. So the center is probably the most important part because then you can look through your graphs and say which one has x minus this number and y minus this number in parentheses. So right now, this one's out because I don't have x plus 2. So that one's out, that one's out, that one's out. So even just with the center, I was able to eliminate 3 of the answer choices here and pick the correct one. Now for this one, they told us that it was centered at the origin. If you average the 2 coordinates they gave us, you end up with 0, 0. So yeah, I shouldn't have any x minus a number or y minus a number on the numerators. So that didn't help me to find the center on this one. The major axis length, remember that means all the way across the shape. So since we have a vertical ellipse in this case, I know it's going up and down because it's the y direction that the foci are going in. So the major axis length is all the way across the shape, but A is just half that distance. It's like the radius of the shape, the long way across. So I needed to cut that in half to get A equals 20. And if you square that number, it's 400. Now I know this number needs to be going up and down or in the y direction. So I was looking for a 400 underneath the y variable. This one doesn't have that. This one doesn't have that. And this one doesn't have that. So just by knowing which variable A goes with, I was able to pick the correct choice. Here's another conic section. If they give you 2 coordinates, it doesn't matter what the coordinates are. Find the center of them. That's always my first recommendation. So negative 3 and negative 3, it's still going to be negative 3 for the x value. For the y values, if you average negative 2 and 8, so 8 minus 2 is 6, divided by 2 is 3. So now I know what numbers I should have for x minus and y minus on top. So if you go through, that should eliminate a few of your answer choices. They also gave me the distance between the vertices. This is kind of like the major axis endpoints for the ellipse. So again, I needed to cut that in half to determine that A was 4, And then the equation uses a squared, so squaring that number gives you 16. It's also helpful to recognize that this one is again going in the y direction, so that means I need the a squared underneath my y variable. So I need a 16 underneath y, so that eliminates that one and that one. Between these two choices, I can't see the signs, but I think I was able to pick out of these two just based on the x plus 3 and y minus 3 on top. And here's the conic section being evaluated graphically. So identifying the location of the center, it looks like that was x equals 1, y equals 2. So then you can go through and say which ones have x minus 1, y minus 2 on top. So it looks like that answers out. That one might be out as well. I can't see the sign very well on this. And then your a value is the distance from the center to the vertex of the graph. So I just measured how far is that horizontally. So that was a length of 2. And the c value is the distance from the center to a focus. It doesn't matter which one you pick. So going to the right, I just measured that length and saw that it was equal to 6. But I don't think I actually needed to work with the focus. There is a formula for dealing with that. But I think just based on the fact that a was 2 and going in the x direction, I knew that I needed that number squared underneath my x. So it had to be a 4 underneath x to pick that answer choice. So that's it for this practice quiz on the units 1 through 3.